Hey yo, this is question 12 on the N25 mock exam paper 2. This is a factors question, and as always, I highly recommend sketching the problem out. We have 2 points A and B, we have the plane alpha, we have the line delta, and we have a plane B containing the line alpha and perpendicular to the plane alpha. Okay, so let this be one plane. This is the second plane. If this is alpha, this is beta. We know that the line delta is in the plane B, or the plane beta. It is contained in the plane beta. Secondly, the normal to plane alpha is perpendicular to the normal in the plane beta. This means that effectively the normal of the plane alpha is another factor we can use to determine the equation of the plane beta. So let's start part A. 153 cross 251. This is equal to, call for the first row. 5 times 1 minus 3 times 5. Go for the second row. 1 times 1 minus 3 times 2. Put a minus in front of it. Go for the third row. 1 times 5 minus 2 times 5. And you will get negative 10, 5, negative 5. Therefore, you can select your normal to be, part B. Part 2. We want to find the equation of the plane beta. To find this normal, we need to find 2 vectors that lie on the plane. This vector here can be used as 1 vector on the plane if we just bring it over here. Another vector we can use is the direction vector of delta. So essentially, you have 2 vectors we can use: normal of A, direction of delta. Cross them, and you will get the normal of beta. This guy basically gives you the normal of beta. But we can pick a nicer normal that is easier for us to work with. So we can select the normal of beta to be 2, negative 1, and 1. The plane beta contains the line delta. So let's pick a point that lies on the plane delta. 1, 1, negative 2. Lies on delta. So we can write our equation as 2x minus y plus z is equal to c. Plug the points in. Therefore, 2x minus y plus z plus 1 is equal to 0. Done. Part B. H lies on beta such that AH is perpendicular to beta. M is the intersection of the planes alpha, beta, and gamma. So we already know that alpha is perpendicular to beta, and they will intersect in a line. We need to find the intersection of the three planes. Okay, let's just say point A is somewhere over here. It doesn't really matter where it is. We know that AH is perpendicular to beta. And this point of intersection is H. So let's construct the equation of AH. Because AH is perpendicular to beta, this means that the direction vector of AH is equal to the normal vector of beta, or 2, -1, and 1. We also know that the line passes through point A with coordinates 4, -1, and 2. Therefore, the equation of AH is going to be 4, -1, 2 plus t times 2, -1, 1. Now we want to find the intersection between the plane and the line. 2 times 4 plus 2t minus -1 minus t plus 2 plus t plus 1 is equal to 0. And from here, you can deduce the coordinates of h. Second part, we now want to find the intersection of the three planes. So alpha has this equation, beta has this equation, and gamma has this equation. So this is going to be a good on row reduction. Row 1 minus row 2. Row 1 minus 2 row 3. And then let's skip row 3. Y is equal to 1. Z is equal to 2. And X is equal to -1. Therefore, point M has coordinates -1, 2, and 1. We also found the coordinates of point H. Therefore, the distance HM is equal to the square root of 1 squared plus 1 squared plus 1 squared, or root of 3. Not too bad. The plane pi contains the line delta that is equidistant from the points A and B. There are two such planes. This is the most creative part of the question. So, visualize this. We have point A, we have point B. we're interested in the plane that is equidistant from AB, that also contains the line delta. So you have two options. Option one is when the plane is parallel to AB, also contains the line delta. Why does it work? It works because this distance is equal to that distance. So this is going to be part C. This is not the only possible arrangement. We can also have the plane perpendicular to AB, where the point of intersection between AB and the plane is M, or let's call it N, the midpoint of AB. It is the equivalent of constructing a perpendicular bisector. So let's start with part C. If pi is parallel to AB, this means that we have two vectors we can use to construct the equation of the plane. We can use vector AB, or we can use, or more precisely, a vector that is parallel to AB, let's say this green thingy, and also the direction of delta. That green thingy is parallel to AB, so therefore this vector is equal to the vector AB, which is equal to negative 2, 2, 2. We already found that r theta, the direction of theta, is 1, 5, and 3. So AB cross r theta, it will give us, go for the first row, 2 times 3 minus 2 times 5. Go for the second row, negative 2 times 3 minus 2 times 1. Go for the third row, negative 2 times 5 minus 2 times 1. You will get negative 4, 8, negative 12. And you can pick your normal to be 1, negative 2, and 3. So as before, we know that the point 1, 1, and negative 2 lies on delta. Therefore, the equation of the plane is going to be this guy. Any equivalent answer will get full marks. So if you choose not to reduce the normal of pi, for example, that is totally fine as well. The last part. So this is actually a lot easier. We know that N is the midpoint of AB, so we can read off the coordinates of N straight away. 3, 0, and 3. Because this is perpendicular to the plane, AB is also the normal of the plane. And we can take the normal to be -1, 1, 1. Therefore, minus x plus y plus z is equal to c. You know the ports, you plug it in, and you should get this as your final answer. So this is the end of question 12, and this is also the end of the exam.